Good morning, everyone, and welcome to the day two of the course R for Data Analysis from Fundamental to Advanced Application, a course offered by Department of Statistics, University of Calicut. We have already discussed the basic introduction to R and installation of R. We discussed about different data types and all, and also we have started discussing on the data structure in R. We already covered the basics vectors and list. We will discuss further with list today, and we will start with list data type, and then we will go forward. Okay. In between, if you face any questions or if you are seeing any questions and all, please let me know so we can definitely uh, discuss those things as well. Okay, perfect. Now, data structures in R, vector, list, matrix, and data frame. We have already discussed these are the different type of data structures in R. Vectors we have already discussed, vectors are the most basic data structure in R. They are one-dimensional array and that can hold numeric data, character data, or logical data. And we can simply using a C function we can create the vectors in R. So some examples we have already seen, and we have also discussed how to access a vector element and how to see those things and all. Okay, and how to update those things and all. Now, we also discussed some of the vector operations and all. The second one we have discussing was actually list. Lists are the more flexible than vectors. Okay, screen is not visible. Sorry. Okay, so okay, lists are more flexible than vectors, and they can hold elements of different types of structure, including other lists as well. That is what we call as nested list. For creating a list, we use the list function. So list function is basically used for creating a list. For example, we can create a list like my list equal to list of something we can even name the elements of the list as well as we did for the vector as well. Name equal to John, age equal to 30, scores, something like that. So we can create a vector like this. Um, and also we can access a list elements using either dollar symbol or double square bracket. So why we need double square bracket to access a list is because in list we have um, different type of vectors are included or different vectors are included in a list. So if you wanted to access some elements of the list, for that we can use a double square bracket, or if you just wanted to access a vector in the list we can use the single bracket. Okay, so we will see some examples here. Mm, okay, so okay. So as we discussed, list is a data structure that can contain elements of different type and different lengths. So, creating a list, as we discussed, we can simply use list function to create a list like this, and we can print the list using print command. Um, and we can also see the class of the list using class command. So it's a list only, and how to access the elements in the list. So as I discussed, like if it is a named list, okay, if it is a named list, if the list has some names for each of the elements, then we can use a dollar symbol to access the name. For example, my list. Okay, so if I okay, so yeah, sorry, my list, and if I put sorry, okay, if I put a dollar here, you can see after oh, it's not my list. my underscore list. Okay, if I put a dollar here, you can see it will show all the elements name. Okay, all the elements with the name it will show. So you can from these elements you can select which element you wanted to select. So for example, if I wanted to select score, I can select the score. Okay, so here it is actually selecting the score. I can also select the score using my list. Okay, and all three. So it will access the third element scores. Okay, here I can also access this one using my list. Okay, so I can try this one. So if I run this one, you can see here it actually select the entire thing. Okay, it actually select the entire thing, the score as a list. Okay, so if I use a single bracket, if I use a single bracket, a square bracket, and select the list object or list element, it will create a sub list. Okay, this is a vector, but it actually select it as a sub list, or it will create the output as a sub list. Okay, that is the difference. So if I use double bracket, then I can explore the element of the I can explore the element of the list. If I use a single bracket, it will we can access the element itself, but it will create as a sub list only. Okay, it won't directly give you the value, it will create as a sub list only. Okay, so if I assign this to some value, um, s list, then if I assign this one, uh, okay, okay, if I assign this to s list, and if I check the class of s list, okay, so it will be a list. Okay, so here I put s list, and I use the class symbol, class of s list. It will be a list. But if I assign this one, this my list to I put a v list, and okay, so v list, and let's access the class of v list. It will be numeric. Okay, so here if we use the double square bracket, we will get the elements of the list. If we use single bracket, it will simply give you a sublist. Okay, so that is the difference between double bracket and single bracket while accessing the element of a list. Similarly, if you're using dollar also, it will directly access the element, so you can get the list, sorry, you can get the elements itself, not the sublist. Now these are similar examples, like we can access name, we can access the second element, or we can access the third element. um, Even we can access the scores, first element of the score. Okay, so like that. Now we can also create a list without name. We don't need to specifically mention the name for a list. So this is a list without a name. So similarly we can access the elements. I'm not sure why the display is going. Okay, okay, just give me a sec. Okay, there's still some problem. I'm not sure. Mm, so I wish to talk video, face views, and translation. Generally, automatically desktop notification, the contact number, of change phone number. Mm, okay, okay. Yeah, I think I will share it once again. Not sure why it is actually going in between. So, I hope it is visible now. Okay, perfect. Great. Here, so we can okay, we can create a list without okay, we can create a list without name also. If you wanted to access the elements of from here, only this dollar operation is not possible. We cannot access a unnamed list using a dollar operation. So otherwise, using double square bracket and a single square bracket, we can simply access the elements as well. Now, how we can simply use the list modifications. So as we discussed in the vector, we can also assign values and modify the list because list is mutable only. List and vectors in R, it is actually mutable. Okay, so here when it comes to list, if you wanted to assign this age, my list, if we go to my list here, so we have three values here. Name John, age is 30, and score is like this. So if I wanted to modify age from 30 to 31, I can simply assign that value. Mile is dollar this one, and I can change the value. Also, I can change the value like my list dollar instead of dollar. I can also use the double bracket to change the name. Okay, or change the elements. Here I change name to Johnny, and also I am updating the scores as well. So my new list will be like this: Johnny, 31 age, and the scores as follows. Now, if we wanted to add a new element to the list, we can simply use a dollar sign, and it's very disgusting. So we can simply, yeah, we can simply add a dollar sign and we can simply assign some values. Here I am assigning gender and my list. So it will be stored as my list. Okay, I'm not sure why it is still doing the same. Give me a sec. I will just rejoin. I will just leave and rejoin. Give me a sec. Okay, hi everyone. So, okay, uh, yeah, hi everyone. So, I'm back. Let me share the screen and uh, let's see if it is okay. Okay, yeah, I hope the problem won't be anymore here. Okay, it is visible now, right? The screen is visible, right? Could anyone confirm, please? Yeah, thank you. Okay, I hope this one come again. Okay, so here we can add a new element to the list, just adding creating a dollar symbol and just enter the new element name, and we can assign the variable. Here we are just assigning gender equal to male, and I'm just adding that value. So if we see the list here as well, we can see four elements are there: name, age, score, and gender. So here also you can see the four elements. Now, if you wanted to remove that one, we can simply put the variable name as null. So it will remove the list element from the list. Okay. So it is again three elements in the list. Now, what is a nested list? Nested list is a list inside a list. Okay, we can create a list inside another list that is called as nested list. For creating that, the operation is same. So we have a parent list, and inside of the parent list, we can create a new list. So here I'm creating a nested list example, and here I am putting list as I wanted to create a list, and inside that one I am creating person. So person details will be another list. Okay, so I'm putting name and age, or even I wanted to add gender. Wait, again stopped. Someone is stopping that one. Okay, okay. Is anyone actually removing the presentation? Is it something like that? I'm not sure because for the first time I'm actually facing this kind of a issue. Uh, because continuous stopping of the presentation. So when I am not sure. Let me try changing the browser. I'm just changing the browser and we'll see once again. Okay, everyone, so I'm just sharing the screen once again. Okay, I just changed the browser, so I think this won't actually uh, go again. Okay, hopefully. Yeah, sorry for the inconvenience, even I'm facing it for the first time. Sorry for that. Okay, so nested list, as I mentioned, like it is a list inside a list. So we are creating a list here. This is the parent list. That is nested list is a parent list, and then inside that one we are creating another list called person. So here also we are putting list, and that inner list contain name, age, gender, and another element in the parent list is called score. Score is having different scores as well. So this is a nested list, and okay, so this is a nested list, and here this list is actually created, and now, okay, sorry, I was on mute when nobody actually mentioned that. Sorry. Yeah, sorry for the inconvenience. As I mentioned, like this is for the first time I am even facing the this kind of an issue. So when I'm not sure, I just changed the browser. Okay, is it audible now? Am I audible and the screen is visible, right? Yeah, thank you. Yeah, I'm extremely sorry for the inconvenience because when I'm not sure about what is the issue, I just changed the browser. I hope this won't happen. Okay. Um, okay. So nested list, we have created a nested list here, and this is a parent list. A nested list is a parent list, and here we creating another list inside this nested list that is called a person. So this is having some personal details of the person. For example, we have name, age, and gender here, and also we have another element in the main parent list that is called score. Okay, so if you consider the parent list, that is having two elements, that is person and score. The person in it is still showing this thing, so why it is actually closing in between. I'm not stopping it. I'm not stopping the presentation and all. Do anyone know what exactly is the problem? This is continuously disconnecting. Setting privacy, clear browsing data. Hardware acceleration setting. Okay. I'm not sure exactly because this is for the first time I'm also facing this issue. Okay, anyhow, I will share once it is stopping. So I don't have any other option at this moment. I will sort it out after today's session. Sorry for the inconvenience once again. Okay, so here person is another list as we discussed. So it is inside a list. Now we can access the elements of the list, nested list, using this way. So nested list, and if I put dollar, I can only see two elements. So score and person. So if you look at score, you can see this symbol that is actually an element. Okay, and this symbol is actually showing as an element of the parent list or data frame or anything. If you put a dollar, and if you can see this one, and this is actually called as element. If you are using a package, and if you go through some functions of that one, there also you can see this one. So this is actually a element, but here you can see another thing, another symbol, so that is actually showing something else is there. Okay, it's not a simple element, it's actually a nested element. Okay, so you can see a nested loop is here. So blue symbol is here, and after that sub, there are two sub values are there, so it is actually a nested one. Okay, so if I click on person, so I can access the values in person. So that is another list, Bob, 28, and male. Similarly, I can access the nested list and scores, so that will show us the scores only. Okay, so if you wanted to access a element in the nested list, or if I wanted to access a um, element in the sub list of the nested list, so I can again use a dollar So inside person, I can again use a dollar and I can access the sub element. Okay, so I can access the name like this, or even I can access the nested list dollar, sorry, dollar person. Okay, person, and I can also access use in this way too. So it will access the age of the person. Okay, now I can access the values in the nested list like this. And from score, score is an element in the nested list. So if I wanted to access the element in score, it will be directly like we seen earlier. So we can access the element like this. Now we can also find another operations in the list, like finding the length of the list. To find the length of list, we can find length. Using the length function, we can still find it, and list length will be this one. Okay, it is 3. So my list, first we check the my list only. So in my list, we have 3 elements, so it is actually 3. Now, if I check the list, okay, if I again wanted to check the length of nested list, I can do the same as well. So length of nested list, so it will also show as the length. It is 2. Okay. Now also I can find the length of scores in nested list. So that is actually score length is equal to length nested list dollar scores. So I can find the length of the element in the nested list. Okay. So now I think Fahima, are you clear with the nested list, or any clarification needed again? Yes, sir. Clear, clear. Okay, thank you. Okay. Now, okay. Now, how to combine two lists? So here, I can combine two lists. So I'm creating a list A as X and Y, and also creating a list B as Z and W. For combining a list, I can simply use the vector function, C function, and I can paste list A and list B. So it will give a combined list. So if we look at the combined list, it will have all the elements of list A, B, and sorry, list X, Y, C, and W. Okay, so it will have all the elements like this. Okay, so this is how we can combine the list also. Similarly, we can check for the null values and all, as we uh, seen earlier. Okay, so okay, now similarly we can check for the null values as we did for the vectors. So for null values, I can check the null values using either we can do it in this way, sapply, using sapply function, and my list is dot null, so it will check for is dot null values in the list. Okay, so now we have to see about the apply function. So apply function we will discuss in detail when we go further. Okay. um, clear. Okay, So here we just using the apply function, and we pass the sapply function, and it will simply checking my list and is dot null. So it is checking any is dot null is available in my list. So it is checking for all the elements, and saying that in each element any null values are there or not. Okay. So here we can see everything is false now. So that is false only. Great. Now we can also apply some functions to list elements. So we use the lapply function for list to. This is actually lapply is for applying functions inside a list. So I will quickly explain the apply functions here, and we'll go back to the uh, list again. Okay. Okay. Apply functions are very useful function in R. Um, okay, so yeah, there are different type of apply functions are there. L apply, S apply, simple apply is there, T apply is there, M apply is there. Okay, so these are the apply functions we have. Uh, okay, V apply is also there. That is okay. Now, now one more thing. Okay, so basically, apply functions are the family of functions in R that allow us to apply a function to elements. Split it. Okay, so basically, apply functions are the family of functions. So we have six apply functions are there in R. Basically, we use the five, and we have we apply as well. So these family of functions allow you to apply a function to elements of a data structure. Like if you wanted to apply something in vector, list, matrix, etc., without a need for explicit loop. Okay, so sometimes we use the for loop, while loop and all. So without the use of those things, loop and all, we can simply apply the functions here. So for that only we are using the apply function. They are often more efficient than the concise, efficient and concise than the traditional loop functions. Okay, so um, so it is actually better than the loop as we discussed. So first we will simply discuss about the loop as well. Uh, okay, we have two levels of loop in R. So that is one is for loop. So for loop is actually used to iterate over a sequence like a vector, list, or range of numbers a fixed number of times. And while loop is basically used to repeat a block of code as long as the specified condition is true. Okay, so this is the two loops we usually use in R programming. Okay, so if you go to Python also you will have for and a while loop. If you go to R and SAS and all, there you have the do loop and for loop. So in general, we do have the for and while loop for the programming languages. Now, what is the use of for loop? Okay, we'll see some for loop example. So for 1 to 5, print something. Okay, print something. Okay, so I am just putting an example here. I am using a for loop, and in bracket I am giving the condition for I in 1 to 5. Okay, the value of I will be varying from 1 to 5. Okay, I is our variable, and I will be taking the values from 1 to 5, and then we will use a curly braces, and we will write the condition inside what should we do for each iteration of the variable I. So here it will print something like print will print something, and paste function is used to paste two values, or two conditions, or two elements in R. So basically here, okay. So basically here, what it is actually doing is we have the iteration number, and we will comma, we will print I. Okay, iteration number, and we will paste I here. So here, for every time the value of I changes in the range of 1 to 5, it will print iteration number of that variable value. Okay, so if I run this one, so you can see iteration number 1, 2, 3, 4, 5. Okay, so for each of the value I is taking place, so it will print iteration number and I is value. Okay, so this loop is applying for. Now I'm printing another one for character in A, B, C. Print character. Okay, and the character name. Similar to that. Now I'm putting another example. V1. I'm putting some V1 uh, as this one, and now I am applying a for loop to this vector. So I'm printing the um, values multiplied by 2. Okay, so I have a v1 vector here, and I'm printing for value in v1. Value is my element, so val is my element, so val is my variable here in v1. Okay, from v1 all the values it is actually taking. Okay, from v1 it is taking the values, and for all the values in v1 it will take the multiplication here, value into 2. Okay, for each of the element in this vector, it will take the values and multiply by 2, and result the output. So I will get the elements like this. Okay, so this is a for loop, and also I can do one more thing. I can store the values for okay. Okay, so for I in sequence along V1, so in V1, for every value in V1, I can print the index and values as well. So index 1, first element of V1 is 10, second element of V1 is 20, 30, third element is 30, like that. We can also do that one. I can also store this one into. Okay, squares of numbers 1 to 5 in a vector. I can also do that. So I am creating a initiating a vector here, squares, called to squares, and then I am applying a for loop here for okay, for I in 1 to 5 squares. So I am assigning the I square values here. I am finding the square of I here, and I am just assigning that value to each of the element in the squares. That is a vector we have just defined. Okay, so I'll just run squares. So squares is now an empty one. Oh, sorry. Mm, Squares is not having any elements here. It is a null vector. Now I'm doing this operation for I in 1 to 5. Squares of I equal to I square. Okay. Now I'm just pasting the squares value here. So it will be 1, 4, 9, 16, 25. The squares of each numbers in one, each numbers from 1 to 5. Okay. So that is squares. Now I will do a while loop example. So while loop is actually something. used to repeat a block of code as long as a specified condition is true. Okay, so it is a conditional loop also. While loop is also called as a conditional loop. For loop is actually a sequence loop. Okay, for loop will iterate until and unless the provider range is there, and while loop will apply until and unless the given condition will violate. So I'm just assuming count equal to 10. Okay. So I just put count equal to 10. And now, while count greater than 0, okay, while count greater than 0, I am creating a while loop. While count is greater than 0, this is a condition I am putting in a while loop. So while condition is count is greater than 0, print paste count is the count value, and then we will count, we will reiterate a count, or we will reassign count equal to count minus 1. Okay, count equal to count minus 1. So whenever for the first time it will take 10. Okay, it will return count is 10, then it will return count is 9, then it will return count is 8. Like that it will go till count is equal to 1. So if count is 1, then after that it will again subtract 1, so count will value will be 0. So there this condition is violated, count is greater than 0, that condition is violated, and the loop will be stopped. Okay, so here you can see it is starting from initial value count is 10, and then it is subtracting count value each time, and once it reach 1 it will print till then, and after 1 it will minus 1 from that count value, so it will be 0. So the loop is the condition is violated, so loop will be stopped. Okay, another example is, okay, so I'm putting another one. So while loop sum equal to 5, I'm giving an I value equal to 1. So if I less than or equal to, while I less than or equal to 5, while loop sum will be while loop sum plus 1. So it will actually store the value to while loop sum, and then it is adding one value. I is starting from 1, and here I is actually adding one value together, and it will reach till I equal to 5. Okay, once I value equal to 5, then it will add the sum to this while loop sum vector, and then it will simply add the value, it will simply change the value of I, and the value will be 6. Okay, here I equal to I plus 1, that will be 6, so the loop will be stopped. Okay, so okay, so it is not defined. Okay, let's define it. Okay, so now if I print a while loop one, while loop sum, so it will be 50. That is the sum of value 1 to 5. Okay, any questions on the for and while loop here? Any questions regarding for and while loop? Okay, I think this is fine. So you're clear with the loops. Any questions? If you don't have any questions, also just let me know so I can be clear, like I can assure like you are listening to me. At least put a message in the chat so I can ensure that. Okay, clear. Thanks, Gauri, for the confirmation, and yeah, thanks, Vismay also. Okay, great. Now, so this is the for and while loop. Now, what we are doing in the apply function? Apply function also we are using the same thing. I'll simply give you an example of for loop in a this one also for loop in one list as well. Okay, I'm creating a for loop here on that I'm creating a list here that is my list, and that is list A equal to 1, B equal to 2, and C equal to 3. And I'm just putting a exam for loop here for name in names of my list. Okay, so for name in names of my list, print element wise name and value. Okay, so I'm just printing the element wise name and value here. Uh, okay, and I can also create a multiplication table using a for loop. So here multiplication table matrix and number of column 5, and okay, I think we didn't discuss about matrix, but we'll discuss that. So here I'm creating a multiple table also multiplication table as well for 5. Uh, okay, so this is a double for loop. Here we have a matrix that I am creating a matrix that is 5 by 5 matrix for I in 1 to 5 and j in 1 to 5. Okay, for I in 1 to 5 and j in 1 to 5. So here I have I and j. Two variables are there. Multiplication table I comma j equal to I multiplied by j. Okay. So this is actually what we are calculating here. So creating a multiplication table, and my multiplication table will be like this: 1 times 1 will be 1, 2 times 1 will be 2. So it is a cross multiplication table. Even I can update it and do 10 by 10. Okay, so it will give you the 10 by 10 multiplication table. Uh, okay. Okay, so in this way also I can do the multiplication table. So it will print the multiplication table for 1 to 10. Okay. Uh, Now one more thing I'm just putting here. Um, okay, so I'm creating a nested list as a square of each element in list using for loop. Okay, so here I have a nested list. So I'm creating an empty list, nested list here. And now for names in my list, names of my list, I'm just creating this one. So okay, nested list name equal to my list name dot name square. Okay, so it will create a nested list like this, and print a list. Okay, so here my list is there A, B, and C. I wanted to create a nested list that will be having the squares of these list. Okay, so I'm just using this for loop here, and my nested list like it will have the squares of each of the numbers here. Okay, squares of each numbers here. Okay, So this is how we can create do some operations inside a list as well. Now we'll come to apply function. So we have six type of apply functions. So as I mentioned, apply functions are the family of functions that in R that allow us to apply a function to an element of a data structure like a vectors, list or matrix without the need of any explicit loop. Okay, so this is very faster. Apply functions are very faster and it can be used inside any of the data operations. Even this is very helpful when we are using the tidyverse environment and all. So that is why we are more preferring apply functions over the loop and all. And there is one more reason for that. So R is actually a vectorized program. Okay, R is a vectorized programming language. So that is why we are using the apply function instead of the loop operations and all, which will take more time and effort to create a function. Now, first, we will start with lapply. Lapply applies a function over a list or vector and returns a list. Okay, so this is also an interview question you can actually keep in mind. So lapply, lapply will actually uh, lapply functions can be applied throughout any list or vector, but it will return a list only. Okay, it will return the output of the lapply will be a list only. Now, sapply functions are there. Sapply, in sapply actually, okay. So, sapply function, it is similar to lapply only, but it actually tried to simplify the result to a vector or matrix. Okay. So, lapply and sapply that can be applied to a list or vector, but lapply will return a list, but sapply will return a vector or a matrix. Mostly it will return a vector. For our day-to-day operation, we will get a vector output only. So sapply will give you a vector output, lapply will give you a list output. Okay, that is the difference. Now we also have a apply function. Apply function applies a function over margins of an array or matrix. Okay, so apply function will give you something in a result. It will give you an array or matrix. Okay, we can apply it to any array or matrix. Array can be vector also, because vector is a one-dimensional array. Vector or list of matrix, we can apply the apply function and it will give the same thing only. Now tapply applies a function over the subset of a vector based on factors. Okay, tapply is something we can apply over a vector based on factors. Okay. Now mapply is there. Mapply is multivariate apply function of sapply. Okay, it applies a function to parallel over multiple argument. And we have vapply that is similar to vapply but allows you to specify the type of return value. Okay, so vapply will allow you to specify which type of return value you need. Now the most common apply function we are using is lapply, sapply and apply function. But even sometimes we won't use the general apply function. So mostly we use these two things, lapply and sapply. So in most of the interviews also, if you are giving a good rate of R programming skills, then you will get a question like what is the difference of sapply and lapply. So the answer is simple. lapply, lapply and sapply can be applied over a vector and list, but lapply will give you a list as an output, and sapply will give you a vector as a output. And sapply is more useful when it comes to a data frame and all. So we need a some kind of a vector kind of a output for the data frame columns and all. Okay, so when it comes to a real data and all, sapply is more applicable in a real scenario. Okay, so that is the difference between sapply and lapply. Great. Now, another thing is, yeah, so now we will see some examples of the lapply. So here I'm creating a list here. Okay, so I'm creating a list here. So this is actually my list. I'm creating a my list, and my list will be like the values will be 1, 2, 3, 4, 5, 6, 7, 6 to 8, 10, and 11 to 50. Now I wanted to apply the squares of these value. Mm, Okay, first we will find the squares using a for loop. So I am creating a new list, a square list for. So and I'm using a for loop and creating a square list. Okay, so this is actually the step I need in a for loop to calculate the squares. Okay, for name in names of my list, square list for name equal to my list name square. Okay, so this is actually the mm, okay, this is actually the operation I need for a square list. Um, so while using lapply, it is very simple. Even the syntax wise, it is very simple and it is very easy also. Square list is equal to lapply. I'm using the lapply function here. My list. Okay, I'm passing this list here, and I am creating a function x such that x square. Okay, function of x that such that x will give the x square. Okay, so in this way, I will get the square list like this, as simple as uh, very simple compared to even the syntax or programming speed. It is very simple compared to a for loop and all. Okay. Now another example for sapply. Similarly, using sapply also, we can create a square of this my list. So I'm using, you can see the syntax is very similar. Instead of lapply, we use the sapply function, but the output will be different. So here you can see it is actually giving you a matrix. Okay, it is actually giving you a matrix instead of a list here. So if we check the class of this one, class of square list, that will be a list, and here squared vector, class of squared vector will be matrix. Okay, now if I have a single list, okay, so here I'll give you another example. Okay, okay, I'm just applying I'm creating a list L1, that is 1 to 5, and applying so L2 will be okay. I'll apply L1, and I'm just giving this function called okay. I'm just giving this function uh, x, that x will give x plus 10. Okay. Now I'm printing L2 and class of L2. Okay. So my L2 will be, you can see the list here. It is actually adding the values. Okay. So, okay, L2 is a list, you can see here. It actually add 10 to each of the values. And if you see class, it will be a list. Now, I can do the same here as well for sapply. Um, okay, L3 equal to, okay, list of 1 to 5. And I can create a V1. Why I put V1 is because it will give a vector only. Sapply L3 function x plus 10. Okay, function of x plus 10, that will return x plus 10. Then we will have v1 and class of v1. Let's try this one. So L1 L3 is a list, and v1 will give you similar thing, that will add v1, sorry, add 10 to each of the elements in L3, and it will return v1. So now class of v1 is actually numeric because it's a vector. Okay, now we will see an example of apply function. So any question before that, any questions regarding this one, lapply or sapply? If you have questions, please feel free to ask, because most of you might not be familiar with the apply functions. So real life examples, like we usually do these things in data frames and all. I will just give an example, but we will discuss these things in detail in when it comes to the data frames and all. But I will, as you ask, I will give you an example using a data frame. So mm okay. So I'll give an example of SFLA in a data frame to calculate the BMI from height and weight columns. Okay. So okay. So here create a sample data frame like height and weight, and then weight in kilogram. Now data frame, I'm just creating a sample data here, height like this and weight like this. Okay, so I have a data frame. So now data. So we'll define a function to calculate BMI now. So I have a function like BMI is a function. So here I have this one. Okay, I'm creating a simple function for BMI, like function height and weight, and BMI will be weight divided by height square. Okay, so this is the standard formula to calculate BMI, and it will return a BMI. Okay, I'm just defining this function. So now I have a function for BMI, and I have my data frame like this. This is my data frame, or it will be here. Mm, Okay, where's my data? Data. Okay, so this is my data frame. Now I wanted to apply this function to this data. Okay, so we will use the sapply function to calculate BMI. So data dollar $BMI will be sapply 1 to n row of data and function I calculate BMI data height comma data weight. Okay. So in this way, we can actually calculate the BMI. So my data set will be like this, which will have a BMI column as well. So if I open data, I will have now the BMI as well. So this is a predefined function, and if I wanted to apply this function into a data set or a new variable in a data set, we can actually use this one. So there is an easy way also using mutate function. So um, okay, we can use the same using mutate function as well. Okay, so I'm using this library because we didn't use this library yet. We didn't reach to that point yet, but still for the demonstration purpose, I'm just explaining that as you requested. So I'm just calling the library, and now data will be data and mutate BMA sapply this one. Okay, sapply and function I. The same thing I am applying. Because sometimes we can actually create something throughout the data and all, and we don't have time to use this different things and a for loop and all. So in that case, we can actually do this one. So here I'm just putting another one, SL number, so equal to, I'm putting some random numbers as well, raw number. So I'm creating a column like serial number as well, and I wanted to calculate BMI as well. So I wanted to do multiple operations here. So for those things, I can simply use a mutate function, and inside that I can apply a supply. So that will create a BMI column in the data. Okay, so my data will be like this. Okay, so BMI and serial number. So these are some of the application where we simply use the supply functions in a data frame, because if we have some existing functions like this, some calculate BMI functions will be there. So if we have some real functions and all existing, and we wanted to apply those functions in a real data set, okay, while doing some data frame operations and all, usually we'll use the mutate functions and all to update the data frame and all. While inside that one, if you wanted to apply something, we can actually use this one. So that is on application. Otherwise I cannot directly apply this one inside a yeah. So I'll show one more thing, BMI1. Okay, so here in this way also we can apply this similar thing, but the problem is actually in this way most of the cases we cannot directly apply the existing functionalities directly in a variable. So that's why we use the apply function. And apply function, one of the advantage of apply function is it will do it in the element wise. It will do the element wise operation. Here if I am directly applying this equation here, it will actually apply it to the entire this one entire column only. Entire column it will consider as a vector, and it will apply this function. But here if I'm using sapply, it will do it element wise, like for each row it will operate it separately, and that will be more kind of it will reduce the errors in the operations and all. Okay, so this is a kind of a application, real life application, while we apply the apply functions in data operations and all. Okay, any questions? What is your name? Angelina. Angelina. Okay. So any questions there? Okay, great. So we will discuss these things in detail. Um, this is another example I'm just putting just for a demonstration. Okay, similarly, if you have some marks and all, so I can calculate the average mark. like this using a sapply function. And uh, it will be like this. Okay, a similar example. Okay, so that is about the sapply. Now we will see another example of apply function. So apply function, I will have a matrix like 1 to 9, and so this is my matrix. This is a 3 by 3 3 by 3 matrix, and it will have elements from 1 to 9. Now I will apply the apply function to calculate the row sum. So I'm calculating row sum as apply my matrix 1 comma sum. Okay, now row sum. Why I put 1 is because it's a row wise operation. That's why I put 1 here. Okay. Uh, Now my row sums are like this. Now similarly, I can apply the column sums. So for column sums, we will do the dimension as 2. So it will create a column sum. Okay. My matrix 1 is for column operation and 2 is for row operation. Sorry, 1 is for row operation, 2 is for column operation. Okay. 1 is for row operation and 2 is for column operation. That is the index. So here we don't need to specify the variable and all. We can do the column or row operation directly using an apply function, and the result will be like this. So yeah, as we mentioned here, it will return a array or matrix as a output. Okay. Now the class, if I check the class of row sums, so it will be integer, because integer is a vector. So the call sum is a vector, so vector is a one-dimensional array. So that's why. Okay, this is the example for apply function. So only thing is in apply function we need to mention like this one, row sum or columns. So we are calculating row or column. Okay, so I can also show you one more thing. I can attach the row sum to matrix. Okay. Okay, so now I can attach the column sum and row sum to the matrix itself. So for attaching a column, so call sum will be column sum. So that will be in a row. So I use r bind to attach that one, and argumented matrix. If I wanted to attach the row sum, that will be in a column. So I am just putting the row sum. Okay. Sum of columns. Okay, so this way I can add this thing. So it will have the call sums and row sums. Okay. Or if if I don't want the complete sum, I can remove this as well. So okay, so I'll get it like this. But this value is not correct, so that's why we just added this one. So because one value is actually missing. So as we discussed, like if for a vector operation or a matrix operation, if something is entered, it will repeat the element from the first. So that's why it's showing like this. So if I don't want, I can put NA. Oh, okay, sorry. Okay, so if I don't want a column sum here, I can put NA. Otherwise, I can use the sum of this call sum. Okay. So it will give you the call sum and row sum of the matrix. Okay, now T apply. So I'm creating a vector here. So 10, 20 up to 60. Now I am creating a factor. So as I mentioned, T apply is actually used for um, yeah, T apply is actually used for calculating something to a factor. Okay. So I have a data and I have a group. So if I wanted to calculate the mean for each of the group, now I can do group means data, group and mean. So it will calculate the group wise mean. Okay. So mean of A is actually 10 and 20. So mean is 15. For B it is 30 and 40, 35. C it is 50 and 60. So it is 55. Okay. So class of group means will be array. Okay. So that is an example for T apply. Okay. Now when it comes to this one M apply. So I'm creating a function like add function, that is adding x comma y. So I'm creating a vector here. Vector 1 is 1 2 3 and vector 2 is 4 5 6. And now I'm just putting m apply and add a function. Then I am passing vector 1 and vector 2. So it will add corresponding elements and give us the value. Okay, 5 6 7. So it actually give the value like this. Okay, class will be the class will be an numeric because it's a numeric vector only. And v apply, we'll see some example of v apply as well. So v apply result, I'm creating a function like v apply. um, so I'm passing my list here and using a function x sum of x, then numeric 1. So I am here mentioning like I need a numeric output. Okay, I am specifying which type of output I need. So the vapply result, it will give like this. Okay, so anyone know what is numeric 1? What is numeric 1? Why we put numeric 1 here? Are we stay connected? Hello, are we still connected or?
Yes, Nagesh.
Oh, thank you, ma'am. Okay, so why we have the numeric one is because numeric one. Okay, still again. Okay, numeric one is because it is actually mentioned numeric of one create a numeric vector of length one with a single element initialized to the value 0. So here for each of the values, each of the elements, it's actually creating a numeric one vector. So for each element of my list, it is actually creating some. So that's why we put numeric one. Okay. Okay, so if I put any other values like the value should be uh, must be matched to the length one, because here the result is actually of length one, that is why it is not showing a result of 3. Okay, so numeric one simply means it is actually creates a numeric vector of length 1. Okay, inside numeric what we are giving is actually the length of the numeric vector. Okay, so okay, here if you go to the my list, you can see here my list will have three elements. So each of the elements we need a sum. Okay, that's why we are creating for each of the elements. It is creating a one digit sorry a single length vector and return that vector. For A it is creating a single length vector, B it is creating a single length vector, C it is creating a single length vector. Okay, so that is what V apply is actually doing. Okay.
Sir, the screen is not visible.
Oh, sorry. Yeah, thank you for mentioning that. Okay. So here you can see if it is in A, we have five elements in A. That is a first element in my list. So five values are there in A. As for A, it is actually creating a, single value. B also it is creating a single value. C and also it is creating a single value. So that's why we use the numeric one here. Now, yeah, in summary, we use the apply function in R actually provide a powerful way to operate or perform the operations on data structure without the need of any loop conditions and all. Okay, so that is about the apply function. Any questions on the apply function till now?
Sir,
Yes.
ന്യൂമറിക്കിന്റെ ഉള്ളില് ആ വണ്ണല്ലാണ്ട് വേറെ വാല്യൂസ് കൊടുക്കുമ്പോ എന്താ പറ്റുന്നതെന്ന് ഒന്നുകൂടെ പറഞ്ഞു.
Okay. So here actually we are using the sum function. Okay, sum function is actually giving a sum of these values. So that will be basically it will result in a single value. So that's why we are using the numeric one. If I put numeric two, I don't have a output of size two when I calculate sum here. Okay, so so it will throw an error here. So it is showing values must be of length 2, but I am while calculating sum I am getting the result length that is 1. Okay, so that is a error it's showing. But if you are calculating the some other things uh, confidence interval or something like that, in those cases actually you can put numeric of 2, so it will have some numeric 2. Or if you are calculating the summary, you can put numeric 5. Okay, so there you can actually get the numeric 5 output. uh, Okay, so here I'm putting n2, that is my list, and the function I am applying x. So it will give you a vector of minimum and maximum of these elements in my list. So here min is minimum of x and maximum is maximum of x. So here I am putting numeric 2. So I am giving the n2 result. So I will get numeric 2. For every A, B, C, each of the elements in the list, I am getting two values here. Okay. So here if I put 1 also, it will throw an error. We are asking for length 1, but our result is giving length 2. Okay. So confidence interval and all, while calculating the confidence interval and all, we can use the same approach, because mm, because for the confidence interval calculation I have to do a lot of things here, to find a test or something, and need to do that. So that's why I'm ignoring that one and simply take the minimum and maximum. Okay, so for those things, like when we are actually creating some numeric reports and summaries of the data and all, so that time what happen is actually sometimes we need to indicate the uh, uh, test statistics or test outputs and all with the confidence limit and all. So those times actually we need to create separate elements. Sometimes the confidence interval in numeric 2 format, and some other things like if it has having a p-value, g-value and all, so then numeric 5. So those kind of things we need to apply somewhere. So in those situations we usually put the values there. Okay, clear?
Yes, sir, clear.
Yeah, thank you. Okay, great. So that is about the apply functions. Still, okay, great. So we'll save this part and we'll move to list again. So applying functions to list-wise elements. So that is where we left, and we move to apply functions and all. Okay, now we will discuss the applying functions to element wise, list element wise. So okay, so I'm creating a squared scores here. So nested list underscore dollar scores. I'm applying a function like square of the scores, and if I keep the square of, okay, because we changed the nested list. Okay, sorry. I think I need to run it from here. Let me run it from here because we did some other examples and it got. Okay, so squared scores. So we had the nested list here. So okay, these are this is the score values in nested list, and so I wanted to calculate the squared scores. So it is actually keeping this one. Now I'm using some using sapply to get the vector result. Here you can see it is a as we use lapply, so here we are actually getting a list of output, but actually I need a vector of output, so I use the sapply function instead of lapply here. Okay, now using sapply I'm getting the output as a vector. So I can also do that. So here I created in a separate one. So I can also created this inside this nested one. So nested list score squared. I can okay. I'm not assigning this one. I can directly apply the sapply function and find the squares of score here. Okay. So if I call nested list, I can actually get the square score as a list element itself. Okay, as a list element itself, I can keep the value here. Now, okay, now I'm creating a list of even and odd numbers from 1 to 10 using a loop. So, okay, now, this is an odd even list I am creating, and using a for loop, I am creating this for I in 1 to 10. If I can be divided by 2 and the remainder is 0, then even list it will actually create even odd list and dollar even. Okay, it will create a even list. It's a nested list, but it will create even list inside the nested list. Okay, or else if this condition is violated, sorry, this condition is violated, then it is actually store the values in the odd list. Okay, odd list. Now if I run this one and if I print the list, I can see it is a nested list with two values. Even list is there. First list is even and second one is odd. So even has the even values and odd will have the odd values. Okay, now I can create a nested list as a square of each of the elements in a list using a for loop. This is a square list, and okay, okay. So here we have the my list. My list is actually having three variable: age, name, age, and scores. But what happened is actually if I use the for loop and create a squared list like um, squared values of each of this, first one, the name, doesn't have a square value. So that's why we are only taking okay, we are only checking if the list element name is actually a numeric type. Then only we are doing this operation, we are calculating the squares, and we got the squares of that list for age and score only, not for the name, because that is invalid. Or if I just comment this one, and if I tried this one, then I'll get an error because um, it is having a non-numeric argument to binary operator, because a character doesn't contain a numeric square output. Okay, so that's why we use the condition there, like if condition. If it is a numeric one, then only we are calculating the squares. So we did the multiplication and all, with multiplication table and all we have created. Mm, okay, we did it on the matrix. We can also create it using a for loop. Um, yeah, I think matrix one we actually did here. Now we can move to the matrix form. Matrices. So before that, any questions for nest? Any question for list and all? Till now, any question? Okay. I think then we will take a short break before we start with metrics. We will take a short break for 5 minutes, and after 5 minutes we will be starting. And also one I hope everyone is back. So we'll just see. Okay, so am I audible now? Great. I think we can get restarted. We'll resume the session. Okay, so now we will discuss about the matrices. So a matrix is a two-dimensional data structure in R that contain element of the same type. Okay, unlike a list or like the vector, a matrix also is a data structure that contain the elements of the same type only. Matrix cannot contain different type of elements in R. Now, how to create a matrix? Like list, we will create a matrix using the matrix function only. So we have a matrix function in R, so that will create a matrix. And while creating matrix, first we need to mention, first we need to mention what are the uh, elements we are passing to matrix, and then we will mention number of rows and number of columns. We can also do in this way. Either we can put a number of rows or number of columns. So based on that, the second one will be auto detected. Okay, here I am creating a 3 by 3 matrix like one using 1 to 9. So and I'm putting it as 3 by 3 by 3. 1 to 9 is there and 3 by 3 is there. So I'm getting a 3 by 3 matrix like this. Now this is I am actually creating this vector using the column wise. Okay, we are creating the matrix in column wise. So first it is filling the first column and then second column and third column. Now I can also create a matrix using a row wise. So before that I'm just checking the class of matrix. Okay. Now creating a matrix by specifying the data row wise. Okay. For that I can do the same thing, and by row equal to true is that what I am actually putting here. So by row equal to true, it will create it by row. Now you can see matrix B. It is first filling the row and columns accordingly. Okay, first filling the rows. Now we'll see how to access the matrix elements. And before that, we can also, as I mentioned, like we don't need to specify a number of rows and columns. Both of these, we can either specify either of this. Only. mm, Okay, I'm only specifying number of columns. So I'm matrix C, I'm creating 1 to 12 and saying like number of columns I need 4. Okay, so okay, okay. So here I'm okay. Here I'm creating a matrix with 1 to 12 and number of columns I'm just assigning equal to 4. Now my matrix C, if I print, it will automatically create 4 columns, and you can see it as we didn't mention by row equal to true, so it is actually creating column base. And also I can put by row equal to true here, so it will create by row. Okay, instead of column, it will create by row here. Okay, so in this way also I can create even instead of n column, I can also mention n row, so it will create the rows accordingly. Okay, so now I have 4 rows instead of 4 columns. Now how to access the matrix elements? So matrix, as you know, as you already studied in school and all, matrix we will have m by n format. So we will have I and j elements in a matrix. So similarly here we are taking I and j. I is corresponding to row and j is corresponding to column. So first value will be corresponding to okay, first value will be corresponding to row and second value will be corresponding to column. Okay, so here I'm creating I'm accessing the second row's third element. So second row's third element, that will be 6. Okay, so I'm just running this one. So I'm getting 8. Okay, second mm, okay, I'm just accessing matrix A, sorry, not matrix C. Okay, let's take it from matrix C. So it is actually 6, and I'm accessing the first row only. If I just want to access the first row, I can put 1 comma. So that will means the column part is empty. That means it will take the entire column. It will only take the row, and it will take the entire uh, column. And similarly, for entire row, we can also keep the row part empty and take the column part. Okay. And now, if I wanted to access a sub matrix, okay. So if I wanted to access a sub, oh, is the screen not visible? Screen is visible now, right? Or is still not visible? Okay. Yeah. Thanks, Kaveri. I think now it is visible. Okay. So okay, here if I wanted to access a submatrix like this, uh, okay, so I am taking first and second row, first to second row, and second to third column as well. Okay, so let's put this one. So this is my one, and I'm taking first and second row. So first and second row I am taking this part, and from here second and third columns only I am taking. So these two columns only I am taking. So I'll be selecting 2, 3, 5, and 6. Okay. So as you can see here 2, 3, 5, and 6 is only I am taking. Okay. This is how I can access a sub matrix from a matrix. We can also, as we did for other data structure, all the data structures are mutable in R, so we can modify the data structures as well. So we can modify the metrics as well here. Now I can change a value, matrix C 3 and 4, third row and fourth element. So that is 9. Instead of 9, we can change it to 20. So mm, matrix 3 comma 4, third row and fourth column. Okay, third row and fourth column is not there. Sorry. Uh, fourth, I'll change it. Fourth row and third column. Okay, I actually kept it in that order, so that's why it's showing that one. So sorry, because currently I just changed the example. So um, okay, third column 20. So fourth row and third column, so that is 12. I am changing that 12 to 20. Okay. Okay, so you can see that that element is actually changed to 20. Now also we can add a new row to a matrix. So new row, I can mention a new row like this, and I can use the rbind command to create a or append bind the vector to the matrix. Okay, so if I can see here, the new row is like this. Adding a new column to matrix also, I can either create a new column like this, or I can directly add values to a matrix using cbind. and matrix C, then I can give the values which are applicable. So here also you can see, instead of creating a new row like this, you can directly put the values here as well, or you can do it in this way. If you are doing it in this way, you can see this one will be the raw name for that row. Okay, but if you are using this operation, there won't be any. Oh, sorry. Yeah, if you're using this operation, there won't be any this one. Yeah, any name for new row or new column. Okay, so here there is no name for the new column. Okay. Now, similarly, you can remove a row from the matrix as well. So, if I put -2, so it will remove the second row. Okay. So here you can see we are removing the second row. Here, second row is not there anymore. Okay. Second row is removed. Similarly, using a minus sign, we can remove a column as well. So we are removing the third column. So third column is removed and it is replaced by the fourth column. Now we can do the matrix operations as well, similar to the other things we have. So we have two metrics. We can do the element wise operation. So this is as similar what we have studied in the metrics during our school time and all. So okay, so we can do the matrix operation, element wise operation. So I'm creating a metric B and E. So I'm just adding. So if it is a same, like if the matrix is in the same dimension, then it will add element wise multiplication. So okay, for element wise multiplication, okay we can do that. But for element wise multiplication, we have one condition. What is the condition there? For matrix multiplication, there is a condition. For element wise multiplication, there is no condition. Like it will directly multiply the corresponding elements only. But for the matrix multiplication, there is a condition. What is the condition? You all are mathematics students. So what is the condition for matrix multiplication? Anyone? Are we stay connected? If I'm asking something and no response is there, I'm also doubtful like we are connected or not. Okay, symmetric. Yeah, so if we need to multiply two matrices, then definitely the condition is the number of columns in the first matrix must be equal to the number of rows in the second matrix. Okay, number of rows of the first matrix and number of columns of the sorry, number of columns of the first matrix and number of rows of the second matrix should be equal. Okay, then only we can do the matrix multiplication. So here I am creating a matrix F and a matrix G. Like matrix F have two rows, three rows and two columns. Matrix G have two rows and three columns. Okay, so for matrix multiplication, we actually use this symbol, percentage star percentage. Otherwise, if you simply use a star here, then it will only do the element wise multiplication. If you wanted to do a matrix multiplication, that is what we studied in mathematics class, then you need to put a percentage star percentage. So then it will do a matrix multiplication. So you will get a resultant value like this. Okay, and transpose of a matrix, we can do the transpose matrix like just adding a t before that. So in data frame also you can transpose a data frame, because a data frame is a matrix format, so you can transpose a data frame also using the t command. It is very easy. So just adding a t before the matrix, you can transpose the matrix. Now this determinant of a matrix, we can simply calculate the determinant of a matrix. So okay, so this is a matrix, square matrix. For calculating determinant, we need a square matrix. I am creating a square matrix here, and determinant value we can simply use the det function, so that will calculate the determinant of the matrix. And also we can calculate the inverse of a matrix. So in the simple matrix operation, we use the solve function to calculate the inverse of the matrix. Okay, so this is actually the inverse of the matrix. Okay, so solve will simply calculate the inverse of the matrix. Now eigenvalues and eigenvectors. So eigenvalues, we can use the eigen function, so that will return you the eigenvalues as well eigenvectors. It will result you a list that will having value and vectors. Okay, so this is the eigenvalues, and this is the eigenvector of our matrix, square matrix. Now row and column sums, we can calculate the row sum using row sum function, and column sum using col sum function. Okay, uh, so row sum, it will be um, calculate the row sum, and col sum will calculate the column sum. Now applying some functions to matrix elements, we can use the apply functions. So squared matrix, we have we use the apply function, and then apply the square to matrix D. Okay, so it will create a squared matrix. Why I'm using C of 1 and 2 here? Because if I'm using 1, it will do the row wise operation. 2, it will do the column wise operation. So if I wanted row and column wise, I'm just putting 1 and 2. So it will do the column and row wise operation. Now we can also calculate the summary statistics for the matrix. So we can do col means apply matrix 2. 2 means column, and then mean. So it will give you the means of each column. Okay. Then also we can do the row wise and summary statistics as well. So we can do it in this way. Okay. So instead of 2, we will put 1 for row. Now naming row and columns, we can also name the row and columns in matrix. So row names of matrix, we can mention the row names. Call names, using call names, we can do the call names as well. Now if we call matrix D, then it will have, instead of 1 comma 1 and 1 comma, we will have row names and column names like this. And if we have names of the columns and rows, we can access the names and named rows and columns using a dollar symbol. So okay, okay, like this, we can access the row and column. So matrix. Okay, this is how we can access the different elements. And if you put dollar symbol also, I can access the values, but it is actually giving that error, like a dollar operator is invalid for atomic vectors. Okay, so for matrix, we can if we use the dollar operator, it won't actually uh, give you the values. Okay, why? Because we have the row and column combination in matrix, so that's why it's not showing um this one while using the dollar symbol. Okay. Okay. So I think that is about the metrics. Um, okay. Now the dimension of the metrics also there. So we will simply. Okay. Before that, we will check the metrics dimension. Okay. So dimension of the metrics. So here on dimension. Using dim function, we can calculate the dimension of a matrix as well. So using dim function, we will calculate the dimension of the matrix. So okay, it will show the dimension of the matrix in m by n format. Okay, first one will be row and second one will be column. Now combining matrix, we can combine the matrices as well. So I have a matrix H as 13 to 18 and two rows and three columns. So we can combine it in row wise as well. If you wanted to combine it row wise, we can use R bind, or if you wanted to combine the matrix in column wise, we can combine it using C bind. Okay, we can combine the matrix in column wise. So this is how we can combine the matrix. Any questions in matrix? Otherwise, we can move to arrays. Any questions for matrix? Any questions so far? Okay, great. Okay, now we will move to arrays. So arrays, as you know, it's a multi-dimensional data structure. So now it's a multi-dimensional data set, data structure in R, and also as we discuss about matrix or vector, it's actually similar. It can only contain the same type of elements. So as we discuss, vector is a one-dimensional array, matrix is a two-dimensional array. So now we can try creating a three-dimensional array. Okay, so for creating array, we will use the array function, and here we will give the values. First, we will pass the values like as a vector, or the values in any form of a vector or a singular form, and then we will use the dimension format to use the dimensions, specify the dimension. So here we will have three rows and four columns, and then two arrays are there. Okay, so if we create this array, we will get something like this. So we will have two arrays with three rows and four columns each. Okay, so three rows are there. For each of the arrays we have three rows and four columns, and similarly we have two arrays as well. Okay, so the rest of the things are same as matrix. Array, we can access the array elements. Class will be array. We can access the array elements using these three formats. Like okay, so if you wanted to access the array element, we need to specify uh, which row, column, and which array. Okay, so it will here it will take the second element, second row, third column. So second row, third column, that is 8 in the first array. So that is 8. Now if you want to know the entire second array, we can yeah, we can actually call the array using two empty columns, commas, and then the array number. And if you wanted to access the first element, okay, first row of the all the arrays, you can actually call it like this. If you wanted to access the second columns of all the arrays, you can call it like this. Okay, and if you wanted to create a sub arrays, you can actually call it like this. So it will create a sub array from first array. Okay, so it is creating a sub array from first array. um, okay, so and all the array operations are same. Like if you wanted to modify and all, you can mention the elements name like this, and you can modify the path. And we are not much using arrays and all in our operation. We maximum use the matrix and vectors, not the higher dimensional array and all. So also we can create a new depth to the array. So here I'm creating a new depth new array, and for array binding we use the abind function. Abind function will bind the array. Okay, uh, if you wanted to okay, if you wanted to oh, sorry, I think yeah, screen is visible now. Okay, so if you wanted to bind an array, we will use the abind function instead of cbind and abind. So abind function, we will pass this actual array, then new array array depth we created here, and along we will say 3, because already we have two arrays, two depth are there. So we need the third dimension, we need to increase the third dimension, that is depth we need to increase. So for that we actually use this one. So this is okay. A bind is not there. We'll install a bind. Okay, abind is the package we are using for this one. So abind function we will use to bind the array, and here we can bind the array like this. So here new array is actually added to the array, and also we can remove the depth of an array using the minus symbol as we already did. So this is how we can remove. Okay, so and also the array operations, as we already did, like we can do the addition, subtraction, multiplication, all those things are similar to a matrix. We can do the element wise addition like this. So we will get the sum of the array. We can do the element wise multiplication, product of the array, and we'll get the element wise product. um, so element wise functions, we can use the apply function to create the squares and all squared array, and summary statistics for each depth we can also calculate that. So array and 3 here, 3 means the depth. Okay, one is actually for One is for the columns, one is for the row, two is for the column, and three is for the depth. Okay, here you can see the mean of the each of the array based on the depth. Then the dimension of the array we can find it using dim of array. So it will give you the dimension. And naming dimension and all those are the similar things as we discussed for the metrics. So any questions so far to um, vector, list, matrix, array? Any questions so far for these data structures? Any questions? Okay, I hope there's no questions. Okay, then we will move to mm, okay. Then we will move to the data frame. So that is the most important thing, and we regularly use data frame and tables in our data analysis and all. So we will go to the data frames. Okay, it is actually part of the data structure, but I'm creating a entire new session for data frames. Okay, so data structure, data frame. I'm just naming it like this. Data frames. Okay, so basically data frames. These are the common data type when we deal with the actual data or real data we have. So I'm just clearing all these things here. You can actually clear the stored values from here, and I'm also clearing this one. So you can use the Control L option to clear the console as well. Okay. So Control L to clear the console, and you can use this one to clear this clear object option to clear the clear all the objects in the workspace. Okay, so you can see the memory is also released here. Now, okay, now the data frames. Data frames are the tabular data structure that can hold different type of data in each column. Okay, so data frame is actually a kind of a matrix format. It will have the column and row operations, and usually the first row will be considered as the column name, and it can actually hold different type of data in each column. Uh, every column will contain same data type, but different column can contain different data type as well. Okay, So they are similar to spreadsheet or SQL tables and widely used for data analysis in R. Now we are mostly using tuples instead of data frames, because data frames are the older version of the data import or data execution part. But now we have the tuple. Tuple is actually more powerful, and it's very efficient in operation. And currently we are using the tuple, but 90% of the operations are similar in tuple and data frame. So you don't need to separately study for tables. You can rightly do the tables if you understand data frames. Okay, because 90% of the operations are same in data frame and table. We will mostly focusing on the table part while using the data analysis and all, lesser on the data frame, because tables are actually new generation of the data frame, and it is actually more fast and concise. So it will be very fast while doing the operations and all in R. And also now the tidyverse environment system, that is more focused on the tables format instead of the data frames. And also that is faster for loading data, performing operations in the large data and all. So you might be familiar using the read.csv file and also read.csv function. So read.csv and all will actually read the data into a data frame format, but we will be more focusing on the read underscore csv, that will load the data into a table format. That is actually part of the readr ecosystem, or a readr package. So we will be more focusing on those areas rather than completely focusing on the data frame. Because nowadays if you move to an industry, or if you're being a professional R programmer, everyone is actually using tables instead of data frames. Okay, but the basic concepts are the same. So we will be discussing more towards the data frame as a part of the data structure, and we will work mostly on the table part. Most of the 90% of the operations are the same, and all the functions and everything is same in data frame and table, but it is a faster version when it comes to table. Okay, now for creating a data frame, as we discussed, we will use the data.frame function, and here we will give the column names and the column values. Okay, column names and column values. This is a format. So we will have column name, then we will have the column values. So this is a format when we use a data frame. Okay, so okay, now if you create a data frame, you can actually see the data frame value here. And once you open the data frame, you can actually open the data frame in a new tab here. And so what is this one? Okay, apply things example. Just removing that. Okay, you can see the data. You can actually click here and open the data in a new tab, and you can actually apply the filters, and all those things are here from here. You can explore the data from here. Like if I wanted to apply something, I can filter all those things here, um, or I can change the values here. Okay, I can do the filters like this. So I can do the filters and explore the data for an initial purpose. We can explore the data, we can sort the data, uh, we can sort the data based on something and all. So all those things we can actually do from here also. Okay, now, okay, now we, sorry, okay, now we can call the data frame from here. So it will display the data frame here. unlike all the data structure we have discussed, those data structures won't be actually shown in a, new tab like this. Okay, everything will be printed here. If you wanted to view the data set, you can actually use the view function. View function, it will open the data frame in a spreadsheet like format or in a new tab. Okay, so either you can simply write df, so it will show you the df like this, or you can click on view df, or you can even print the df. Okay, print the df, so it will print the df, data frame in the console. And also you can have the commands like head of data frame, so that will give you the first few rows of the data frame. And you can also use tail of data set, that will show you the last few rows of the data set. Here the data set is only having like 3 rows, so it is actually showing everything if you use head or tail. Okay, uh, now you can use the structure function str to understand the structure of the data set. So once you use the structure function str function, actually it will show the structure of the data set like this. Here you can see the structure. If you click on this arrow here, that will also show you the structure here. So if you look at the structure of the data set, it will show you what is the class of this one, that is a data frame, and how many observations are there. 3 observations are there, and 3 variables are there. Okay, and each of the variable it will show name is a character variable, and it has values like this. Age is there, age is a numeric variable, and it has values like this. Height is there, that is also a numeric variable, and the values are as follows. Okay, these are the information we will get from this one. And if you use summary, you will get the summary of the variables as well. Okay, so here you can see it is a character value, so it is only showing length, class, and mode of the variable. Now age, that is a numeric variable, so you are getting the 5 number statistics, and for height as well. Now n row of df, it will show you the number of rows, and n columns will show you the number of columns. Dimension, as in metrics, it will show you the dimension of the data frame. And also call names function, that will show you the call names. Raw names also show you the raw names of the data frame. Okay, these are some basic functions of the data frame. Now how you to access the elements of the data frame. So if you wanted to take the values from rows, you can actually use this format as we seen in the matrix, and columns also in this format. And similar format also we can access the elements in the data frame. But usually we follow a different approach here. We usually use the dollar symbol. Okay, we usually use the dollar symbol to access the columns. Usually we need the columns only from the data frames. For that we usually use the dollar symbol, and from dollar symbol we will access the um, values from the columns and rows. So if you wanted to select a particular element from a row, from a column, you can actually use the square bracket and position. So it will access the second element. So here it is actually accessing the second element from the age column. Now you can also access the height column like this. And you can subset the rows and columns as we did in the matrix like this as well. Also you can access something using a condition as we did in the vector and matrix. So that is also we can use it using some conditions as well. And also we can do some operations. We can add some 5 to each of the elements in a column using this way. And we can also assign that value to the existing value, because here you can see we added a 5 to each of the age, and it simply display, but it does not change the data frame here. So if we assign that one, then only it will change or update the existing value in the data set. So now you can see here it is actually changed. Okay. Uh, Now we can also add a new column using a dollar symbol. Using a dollar symbol, we can create a new column and assign the values accordingly. So my final DF will be like this. Now I can also calculate the BMI like this. So it will add on more column. And also I have option to select some specific columns and display those. For that we will use the df data frame name, then in square bracket comma we will put comma is to select all rows. So as we discuss in metrics, row part we will keep it empty, so it will keep all the rows. Then columns we will specify what are the columns we wanted to select. Okay. So now my df will be like this only. Okay. So now we can do the filtering, and also as we already discussed. Okay. Now I wanted to okay, yeah, okay, filters we already discussed, and this is the output. Only greater than 50 it 30 it will show. And now we can modify the column names of the data frame as well. So I'm just changing the name to full name, age to years, or I can mention it age in years. And okay, so I will change the names like this. So I can access the names of the column using call names. So it will show the new names. Now this is my data frame. Okay. So also I can modify the raw names, but and that is a rare event. We usually won't update the raw names. So similarly as column names, we can do the raw names as well. So now if I call df, it will have the raw names as well. Okay. Now I can remove a column. I can put something equal to null. So it will remove that column. Similarly, we can remove a row as well, df minus 1. That will remove a column. So I can also remove the column also using this way. Like okay, instead of this comma, I can put comma 1. So that will remove the column as well. Okay, okay. Now I have this is on my df. So that is about the basic basic operations we have in data frame. Okay. Any questions here? Okay. Oh, okay. Now we will create another data frame with 20 rows and 5 columns. So I'm using a set seed. So this is actually set the randomness unique. Okay. So set seed is actually used for creating a random element in R, and this will set a random state to 1, 2, 3. So whatever random operation you are doing, that will simply keep the same value. So we can use that one. So I'm creating a, data set, id equal to 1 to 20, and some score, and also okay. And let's put some name as well. Okay, so okay, so I'm creating a student data set. So now we have 6 columns, so let's modify that. So I'm creating some random numbers, and this is my data frame. Okay, so this is my data frame. So okay, here is my data frame. So here also, as I mentioned, we can do some filters, and also I can check for, sorry, okay, 50 to 80 I can mention. So these kind of filters and all I can simply do, or you can simply select these things. So based on the selection it will show. And from here you can also see what is the maximum, what is the distribution, or what is the histogram of these things, and what is the distribution, so where the most of the values are included. So if I remove all those filters, and if I see, here is the most of the values are there. So if I go through, I can see these are the most more values, or more highest frequent values here. So those kind of things I can see here. Okay, so those kind of things and all I can do the filters and all from here itself. And also I can sort it based on the score, uh, whichever scores I need I can sort it out based on that. Okay, like this. Now similarly I can, if I use the head and tail, I can see. Okay, so here you can see, if I use head, it is showing first 6 values, or first 6 rows, and if I use tail, it is showing last 6 rows. Okay, now if I print the data set, okay, so it will show you an error because as we mentioned, print is case sensitive. So we should mention the print in lower form only. R is case sensitive. Okay, every function in R is case sensitive. Okay, it will show all these values. I think it will only show the first 50 lines while we print the values. Now here, structure of the data set, as we mentioned, it will show the structure, it will show the summaries, end rows, and also all the similar operations we have done, it will show. Okay, now we are creating different vectors, and then we can combine those things to a data frame. So now this is another data frame. So instead of creating all the values inside a data frame, we create the structure. We create the vector of each of the variables, and then we create the data frame like this. Okay, inside that data frame we pass the name, and then we pass the vector. So it is actually created a data frame like this. So mixed data frame will be like this, and the structure is as follows. Okay, so that is about the data frames. Any questions so far?
can we comment 5 or 6 lines together without commenting each and every line?
Can we comment?
5 to 6 lines together.
You mean you wanted to comment all these lines?
Yes.
Yeah, you can actually do Control Shift and C, so that will comment. Okay. If you again use the same code, it will uncomment. Okay. Control Shift and C, you can comment it, and Control Shift C, again it will uncomment the same. Okay. Is it that your question?
Yes, sir.
Okay. Okay. Now we can combine two data frames by rbind function and cbind function. So this is my first data frame, and okay, this is my second data frame. I can combine the data frame using rbind function. So here my first data frame, second data frame are there, and I'm just combining those things using rbind. So it is combined, and I can see both of the data sets. So here, this is the first data set, and this is the second data set. Okay, so I just combined these four students together, and of four students together, and combined it. And I can also do a column wise combine using cbind. Okay. Okay. Now I can create a df3 like this one, and I can use cbind to combine it with df1, and the combined values will be like this. I can also save a data frame to a CSV. We can use the write.csv df large. This is the data frame I am saving, and I am saving it in the name df large dot csv, and raw names is false. I am not saving in the raw names, so I'm just saving it. Okay, so you can see here. mm, okay, the data set is actually stored here. Okay, so the same data set we have stored here. Now we can read that CSV file also. So here, df from CSV. So I'm just reading this one. So just to verify, this is the CSV we have saved, and this is the one. So I can check the class of df from CSV. So this is a data frame. So basically, everything we load using read.csv, that will be stored as a data frame only. Okay. We can we can also see the things like the structure of the loaded data frame and all like this using str. So all the similar operations we can do like we did earlier. Now how we can clean up the data frame? If you wanted to remove the file, we can actually use file.remove, and it will remove the data set from the file. Okay. Um, okay. We can also find the length and all of the data frame. Mm, okay, so I'm creating a data frame here, and just running that. And uh, if I put cat length of data frame 1, it will show the total output as 3 element. Okay. um, then so we discuss adding and removing columns and combining data frames. Mm, so all those things we have discussed, and now mm, okay, we can okay. So I'm just using a data set that is a inbuilt data set. So that is called family. Family dot found. So okay, family the rows of data set are family. Mm, so this package is there, so it's not loading. Let's see. The package is already there. Okay, we can we have some inbuilt data set. So that we can actually use. Okay, family is removed. So um, okay, so okay. I think we can see the life cycle saving data instead of this one. So life uh, equal to okay, life cycle saving. We can use this one, and it will store the data to this one. So this is the data set. We have 50 observation and this one. So here, if you see, we have row names, and then we have 2, 4, 5 columns as well. So if you use the um, structure of the data set, then we can see it is having 50 observations and 5 variables. But the raw names are also important because it's actually showing some this one. Yeah, it is actually showing some of the mm, information about the country and all. So we need to keep the raw names also in some variable. So I'm just okay. So I'm keeping life dollar country as raw names of life, and I'm keeping raw names as null. So now my structure is actually changed. So here 50 observation and 6 variables are there. Final column we have created as country. So it's a character variable. Now, if I wanted to know what are the class of every variable, okay. Um, so I can check the class of each of the variable. Class of life will be data frame. Now class of life dollar country, that will be um, oh, it's a null, it's not assigned. Okay, sorry, it's actually capital C, country. And like this. Now, if I wanted to if I wanted to know what are the class of all the variables, so I can use sapply here as well. So sapply life comma class. So I will get the class of each of the variables like this. Okay. Now, if I wanted to find the median of all the columns, I can or mean of all the columns. Uh, So I can use the sapply. Um, First, I can see if using sapply, if I can see, select the numeric columns only. So once we have the numeric columns, we can find the mean values using sapply life comma numeric columns only. I'm selecting numeric columns and then mean. Okay. So now mean values for every numeric values I can see the. Uh, so the screen is not visible. So why don't you tell me that screen is not visible? Sorry. Okay. Okay. So from which part we are missing the screen? Sorry. Okay. I will once again start from the data set. So we are using the okay, we are using the life cycle saving data set, and then uh, this is the inbuilt data set in R. So if we check the structures, we can see here 50 observations and 5 variables are there. But if I look at the data here, here we have the raw names, that is the country names. But raw names actually need to be stored for our analysis, and also we can first remove the raw names and keep it in column. So I'm creating a column like life data dollar country. So it's a new column, and assigning the raw names of this data to that column, and keeping the raw names as now. Okay. So that will store the raw names of